Hey everyone. Today we want to take a look at the unit circle and just some things that you can do with it, namely just finding values of different trig functions. So we will go through that. There are a few things, eventually we'll get to this, right? Finding sine of 5 pi over 3, negative pi over 4, 17 pi over 6, like all these different angles. That's kind of our goal, where we want to end up. Before we get there, we need to talk about, just in case you haven't seen, what does it mean to have these like weird angles that don't even show on the unit circle? Like, what is a negative angle? Or what is this angle 17 pi over 6? How do I find that? That sort of stuff. So usually when we're doing these types of problems, we'll first convert the angle back to one we recognize, and then we can easily fill out the answer. Um, so let's go and talk about that a little bit first. So this is something that is called either a reference point or a reference number. And how it usually comes out is looking at sometimes what's called a terminal point or terminal angle, that sort of thing, and then finding just how close that is to the x-axis. So if we were looking at, say, this 4 pi over 3 is our angle, right? First, we have to kind of know where that is. So a lot of times, how I like to compare it is I know two really nice ones. I know that 0 that's right there, and pi is right here. I know pi over 2, right? 3 pi over 2 are down here, which are basically half a pi and um, 1.5 pi down here. So I'm just trying to figure out where am I at. So this is going to be 3 pi over 3, which is 1 pi plus a little extra, right? An extra little pi over 3. So if you didn't recognize that as one of your unit circle values, then you should. All the pi over 3's are going to be somewhere in this vicinity, right? Like right here. So that's my angle, 4 pi over 3. It's got some coordinate, which we're not going to worry about too much just yet. But that is where my angle is located, right? So there's my 4 pi over 3. And uh, if I want to know this reference number, so reference number, reference angle, right? This is just how far it is to get back to the x-axis, right? So this is my 4 pi over 3 going all the way around here, right? So I'll go and put that in, 4 pi over 3. How far is it to get back to there? And I'll go ahead and see if I can switch up my color real quick. Um, so now, how far is it to go from here, right, to here? And we're looking at a positive value, so just that absolute value distance of how much rotation does it take to get back to the x-axis. So one way of doing it, right, is just if they're close enough, you can kind of just subtract these two, right? 4 pi over 3 minus pi would be that angle that's right there, right? Just the difference between those. So I have all this way I went around, and then I'm just going right back again, just this little amount. So subtracting this whole top half, right, that pi is what you can do. So we could say for this one, right, 4 pi over 3 minus that value of pi, right, is going to be, um, change this to a common denominator. This is often something you have to do, right? So 4 pi over 3 minus pi over 3, that is going to be, or I should say minus 3 pi over 3. That's the same as pi, is going to be pi over 3. So that is the distance, right? Angular distance right there. Amount of rotation that it takes to get that side back up to the x-axis, right? So this would be what we call that reference number or reference angle. Now, if I was at negative 7 pi over 6, right, same deal. Where would that be? How far does it take me to get to the x-axis, right? So if I'm looking at that one, we go ahead and switch this back over to blue. And I might go erase some guys because it can get a little messy for these, just to see what's in there. So for this one, all right, basically we'll just leave that guy right there. at the bottom. This time we are going to go switch this back over to my pen from here in the opposite direction, right? This way. We're going clockwise for negative angles, right? So an angle of negative 7 pi over 6, I'm going to go around this way and end like right here, right? And we know that because we're going 6 pi over 6, right? That would be pi, negative pi, go here, and then just an extra little pi over 6 to get right here. So I kind of already know I'm going negative pi, right, to get to the x-axis right here. And then I'm going an extra little pi over 6 to get up to that 7 pi over 6 that's right there. So minus another little pi over 6. That extra little bit is our reference angle, right? So again, I could just kind of say, all right, well, that 7 pi over 6 that I went around, I'm taking away that pi that's right there. So this extra little pi over 6 angle that's right in there, to get back to the x-axis, that is my reference number. So that's another thing that you can do there. So we would say like negative, what I have is negative 7 pi over 6. This time we're going to add pi, right? So plus pi. And then that is going to equal negative pi over 6. And for, let me see if I can get rid of that for a second. Okay. So negative pi over 6, right, is what I would keep going. But remember, reference numbers are always positive. So when you declare a reference number, that is just going to be, sometimes they'll use this bar notation, like t with a little bar on top. They'll say that is a positive pi over 6 because that's reference numbers are always positive, right? So that's what we call it. It's positive pi over 6. So no matter where it is, right, just remember it's how far to get to the x-axis. And sometimes you can reason them out for things like that. Let's do two more. These are kind of weird, so we'll go ahead and figure it out. 3 pi over 5, where is that going to be? Let me go ahead and erase these other ones real quick, too. Okay, so we're working on this 3 pi over 5. We're just going to need to know where that is, right? And then how far to get to the x-axis. So 3 pi over 5, I could say, all right, well, 3/5, right? That's a little bigger than a half, right? 1/2 would be 2.5 fifths. So we're probably somewhere just past half a pi, not quite to a whole pi, right? So this would be 5 pi over 5 would be a whole pi. About 2.5 pi over 5 would be up here. So we're probably somewhere in this vicinity right here, right? So that is a terrible line, but somewhere, I'm going to try that again. All right, so we're somewhere like right in here, and that angle, right, will go from that 0 over to that 3 pi over 5, right? So that's 3 pi over 5 right there. Now, how far does it take to get back to the x-axis? So with pi, right, this would be 5 pi over 5. So again, I can just kind of subtract those two to figure out, right, how long that would take to go from there back to there again, right? So subtract that whole pi minus that 3 pi over 5 that I already went. So we would say this is pi minus that 3 pi over 5. And that would end up being, right, 5 pi over 5 minus 3 pi over 5 is 2 pi over 5. So that would be my reference number, and you could call that T bar for my reference angle that's right there. The last one, we'll save that one here for a minute. First, let me just talk about the formulas that you can use for these guys. So up here in quadrant 1, a lot of times they'll either use t or thetas. I'm going to use thetas here. So the reference angle of theta up here is actually equal to theta. if you are starting from 0, right, and between 0 and 2 pi. So let me put a big if up here. So if theta is between 0 and 2 pi, 0, 2 pi, right? Quadrant 1, right, theta is always going to be closest to the x-axis, just however far you traveled. So the reference number or reference angle is the same as the angle. Quadrant 2, right, which is kind of what we did for part C here, I'm moving partially into quadrant 2, but not all the way to pi. So to get this reference number, I could say this reference number is pi minus my angle theta. Right, so pi minus that theta will take me over to here. Again, like for part B, right, if I have negative angles, that's not between 0 and 2 pi. So I might need to add 2 pi to get back to a number that's in that range, or just figure it out some other way with distances. But generally, you can always add or subtract 2 pi to get back into this range if you need to. We'll use that idea a little bit later on too. Down in quadrant 3, right, so if I go all the way around to here, this was kind of like if I were to go a positive 7 pi over 6, right, all the way down to here, or like we did with that 4 pi over 3 in part A, right, all the way down to here, then I would go, right, half of this circle, right, which is pi plus some extra, and that extra, right, is what I'm interested in. So all we have to do is subtract this top half of pi. That'll get us what we need. So we'd say down here in quadrant 3, right, theta bar is this, let's see, pi subtracted. Actually, I need the other order on that one. So we'll take our angle and then subtract off that pi, right? So we're going to take this angle theta, right, whatever that was, and subtract off the pi. Right, so that's what we did up here. The 4 pi over 3 minus the pi, and then we ended up with that pi over 3. The last one, right, over here in quadrant 4, let's see what I would do for that guy. So we're going to go, right, all the way around, say, some angle over here, right, so where I'm going to stop. And then I'm interested in just this little bit right here, right? How much more angle do I need to get back to the x-axis? Well, I'm almost a full revolution around, almost 2 pi all the way around. So I just need to take 2 pi, subtract the distance I've already gone, and I'll have just what's left. So over here, quadrant 4, right, I could say this reference angle is going to be 2 pi minus that angle theta that I've already gone, right? So hopefully that makes sense, right? Kind of geometrically, right? How far I go versus how far I've been, how far I still need to go, those types of ideas. So that is a lot of times what you'll use to find these reference numbers. Now how this is going to come up in the next video is basically when I get around, right, to a certain location, right, say I'm right here on this point, um, any angle that ends on that point will have the same x and y value, which means they'll have the same sines and cosines, right? So the same sines and cosines of all those guys. That is what's going to be most useful for me, right? What is the x value? What is the y value? So even angles that aren't between 0 and 2 pi, right? Negative angles, big angles, anything that we're interested in the sine or cosine of, we just need to be able to figure out where is that landing on the unit circle, and then we can get that value right off. So that's kind of the idea for these guys. All right, we will tackle that in the next video though. For this one, let's just go and finish up with this t equals 4, right? This is kind of a weird angle that's right here. So first off, where would that angle be? Let's go ahead and change my color. Where is just a measure of 4, right? This is 4 radians. There's no degree symbol on it. So 4 radians. Let's put in some values, right? This is 0. This is about half a pi. This is pi, which is about, right, 3.14, etc. And then down here, right, is going to be another like 1.5 pi. It's like 5 point something. So 4 is going to lie like right in between. Right? It's going to not exactly halfway, but somewhere in between, right? This 3 and this 5 number that's down here. So this will be my t equals 4, right? Equals 4. So that's going to be coming around here. So what is the reference angle, right? It's just that angle minus pi, right? So that'll be what it is right there. So we would say t bar in this case is 4 minus pi. And if you want an exact value, right, you just leave it like that. If you want an approximation, you put it in your calculator. It's going to be about whatever that difference is, 0.75, whatever comes out for that 4 minus pi. So depending on if you want exact values or calculator estimates, right, it's kind of up to you. We'll just leave it exact for this one. So even though that's a weird number, right, that is actually the reference angle, exact reference angle for that t equals 4, or theta equals 4, if you want to do it that way. All right, in the next video, I think we'll finally be ready to tackle some of those big sine, cosine. We may even do some tangent and secant, right, cotangent for all these guys. We'll see you in the next one.